Hello and welcome to today's lesson. So today we're looking at ozone depletion over the Antarctic. And this is a really nice subject to look at because it's a really good example of how ozone varies with season. So what we're going to look at today is what happens to the ozone layer over Antarctica. Why does an ozone hole develop over Antarctica? And why does the ozone hole heal each year? So to start with then, we need to quickly examine what happens over Antarctica each year and how that has changed since like the 1970s. So if we have here and we've got 100 Dobson units, 200, 300 Dobson units. So that's our thickness of the ozone layer. And then along the bottom here, we've got our seasons. So we've got summer, autumn, winter, and spring. One thing to remember is we are talking about Antarctica. So our seasons are reversed compared to northern hemisphere. Okay, so when it's winter in the southern hemisphere, it's our summer, and when it's summer in the southern hemisphere, it's our winter. Okay, so normally what we see is the ozone layer is reasonably constant until the spring when there's a bit of a dip and then it carries on. Okay, what we've noticed since sort of the 70s, 80s is a much more dramatic change. So we see that the ozone layer has a significant decline at the start of spring and then returns to normal after late spring, early summer. So remember, anything under 220 Dobson units is a hole, or classed as a hole in the ozone layer. So for this time period, in the spring, early spring, mid-spring of Antarctica is there's an ozone hole developing over Antarctica, letting in a lot more UVB, and the worst periods or the maximum depletion occurs in October each year. So you'll often see October being the time when it's worst. Now, the question is, why is this happening? Oh, and not only is it there's a hole developing, but we also have it extending. So the area it covers is getting bigger, or was getting bigger. Okay, so like this is, let's say, the 1980s sort of concentrations that we're seeing, and this is before 1980s. Okay, so why does an ozone hole develop over Antarctica? Why does it keep getting? Why was it getting bigger? Why was it extending over the rest of the planet? So the first thing we have to look at is some preconditions that are unique to Antarctica. And they are seasonal. So what are these? Well, the first one is that it is in the winter, it is completely dark. Okay, and this means that it gets very cold, minus 80 degrees centigrade. In addition to it getting extremely cold, we find that there is a specific climatic condition that develops. So if we quickly draw a little sketch map of Antarctica. So this is meant to be Antarctica looking up at the South Pole. And so we have South America over here, and we've got South Africa over here, and we've got Australia and New Zealand over here. All around Antarctica is ocean. This means there are no mountains to get in the way of wind, so we find that there is quite a strong what's called polar vortex that rotates around Antarctica. And because of the extreme cold in the over Antarctica over the winter, this polar vortex is strengthened. And it's called the Antarctic Polar Vortex, the APV. So the Antarctic Polar Vortex develops, and what this does is isolate air over Antarctica. Because any air from the surrounding regions that tries to get in gets trapped in this polar vortex and does not get into this trapped air over Antarctica. So these are our two preconditions. It gets very cold and we have a strong polar vortex developing.